Okay, so we're going to finish up notes today. Now what we need to do though before we get into these last three is we're going to talk, or especially this one right here, we're going to talk about this part right here. It says the property of equality for logarithmic functions. And that says that if I have the log base a of x sub 1, and that equals log base a of x sub 2, those two are equal to each other if and only if x sub 1 equals x sub 2. Now we had kind of a similar property before. If you remember the property, now we used that property in the evaluate section of this, and it said that if I had a to the x and that equaled a to the y, that's true if and only if x equals y. Well, this is the same sort of property. If I have this log function here, okay, with x1 as my subject of it, or my element of it is called, and if you notice that the bases are the same, if that's true, log base a of this equals log base a of that, that is true if and only this is true. So what that means is, as I come over here to this fourth example, you notice here I have log base 8 and log base 8. Okay, if those two things are technically true, then that will be that is true only if and only if this is true. Okay, and that's a nice property. I mean, I know the last time we did the little triangle right there. Feel free to do that, and then you can just solve. So if I subtracted 3x over, I subtracted the 4 over, so x equals 3/4. It's a really easy idea right there. For instance, here let's do one more. We'll just add one in here. Let's say we said log base 3 of, I don't know, I'm just making this up, but 2x equals log base 3 of x plus 4. Since it, now notice they had the same bases here, okay, so therefore we could say that 2x equals x plus 4. Solve, x has to equal 4. Simple as that. And it's true. I mean, if you take a look, if you were to plug in 4 up to here, this would say log base 3 of 8, and this would say log base 3 of 8. So it's very true. So that's an important idea right there. We'll come back to this idea more later, but that's an important idea. This is one of the things that you should definitely have memorized. Okay, last two examples. Let's talk about these kind of unique individuals. So we want to solve these still. Now, the way we're going to solve these is we are going to change these into their other form. So meaning, if I were to, this is in log form right now, I'm going to rewrite this. Now I'm going to write it as 4 to the x equals 4 to the 7. So you're treating this as one thing. Well, that's not difficult. Look at what we have now. So since now we have the same bases, therefore I can simply say that x equals 7. Okay. Now let's do another one here. Let's just make one up. Let's say I said 5a. What if I said log base 9 of 9 to the, I don't know, 6th equals x. So if I were to solve that, I would write 9 to the x equals 9 to the 6th. Therefore, you could say that x equals 6. Now, do you notice any pattern here between these two problems? Notice here how the answer is x equals 7, and look at the exponent right here. Notice how the answer is 6, and look at the exponent. Okay, we kind of have a little unofficial rule here. Okay, this unofficial rule simply says that if I have log base a of a to the b, okay, so these are the same, the answer is always going to end up being the exponent. Okay, that's kind of a helpful little rule right there. That'll pop up quite a bit, so that's something that's pretty handy. Alright, so let's look at the last one. We're almost done. It's been a long set of notes. I apologize. Now, this one right here. what form is this in, is the first question. I know it has a log in it, and so you might be tempted to say it's in logarithmic form, but it's actually an exponential form because, and hopefully it's obvious, but this stuff right here is an exponent of this. So if I were to rewrite this as a log, so we're going to go from exponential to log form, this would drop down, so I'd write log, this drops down, and these two things switch. Okay, so again, I treated this as just one big thing. So I switched those two around. And now if you notice, what do we have? We have this situation right here, where we have log equals log, same base, so therefore you could say x equals 9. Okay, and that actually leads us to another example, or another unofficial rule also. If you notice here, the answer is x equals 9, and notice that the 9 is right here also. And this is, and we'll do more examples of this, but this is another kind of unofficial rule. And that says if I have a to the log base a of b. So again, you notice that this and this are the same. Okay, that will always equal b. Okay, that's a lot of stuff. So try and keep that straight. If it helps, go back and look over the notes that we just did right there, or re-listen to them. I'm sure we have many examples, or probably many questions. So we'll talk about those in class. So so take your time. You know, make sure you look over this again, and I'll see you in class. Okay, thank you.